Okay, so in Chapter 5 we're going to look at ways to solve systems of linear equations. We're going to start off with systems of just two equations. And so if you just have two linear equations, essentially you have two lines. And so there are three things that could happen geometrically. The generic situation is this first one, and that's when you have two lines of opposite slopes, and at some point they're going to intersect, and so you get exactly one solution. And that's kind of the generic case that happens most frequently. Every once in a while you have two lines that when you plot them, they actually have the exact same slope, and so they're parallel and they don't cross at all. And so that's kind of rare, but in that case you have no solution because there's no point where the two lines intersect. And then even more rare is the case where you have the exact same slope but the two lines fall right on top of each other, and so that would be like this case. You get infinitely many solutions. So again, the first case is the most common. It's the generic case, and then these other two cases happen every once in a blue moon, I guess. Okay. But the point is that it's kind of hard when you just look at a system of equations, or a system of equations, to see which case you fall in unless you do some algebra. So there are a number of different ways to solve systems of equations, and the first way I'm sure you're familiar with is substitution. So in the substitution method, what you're going to do is you're going to solve for one of the variables, and then you're going to plug that back in. So in this case, I think it's easiest to solve for x in the second equation here. So solve for x. And then when you solve for x, you get x is equal to 2y minus 3. So I just added 2y to both sides. And now I can take the 2y minus 3 and plug that into the other equation in for x. So I'm going to get 5 times x minus 4y equals 9, and I'm plugging in 2y minus 3 in for x. And so now that I've done that, I need to distribute the 5. So I should get 10y minus 15 minus 4y is equal to 9. And so I group the y's together. I should get 6y. And then I'll add 15 over to both sides. So 6y equals 24. And again, that's adding 15 to both sides. So y is equal to 6. Is equal to 4, sorry. Okay, so there's my first solution, but I'm not done. Now I need to solve for x. So I go back to either one of the equations, and I plug in y equals 4 in. So I have x equals 2 times y minus 3, and I can plug in 4 for the y. So then x should be 8 minus 3, so x is 5. Okay, so my solution then is the point 5, 4. So for this problem, we were in this first case up here. And we found the point would be 5, 4. There's one point of intersection between those two lines. Okay, now the second case, I think what I'll do is we've already solved for y, so I'll just plug that y equals 3x minus 2 into the second equation, 15x minus 5y equals 10. So here's 15x minus 5 times y equals 10, and I'm going to plug in 3x minus 2 in for y from that first equation. And so now I'm just going to distribute the negative 5, so I should get negative 15x plus 10 equals 10. And now we get, well wait, if I group like terms here, I get 15x minus x equals 0, so I have 0 plus 10 equals 10, or just 10 equals 10, and so that's always true. And so what happened was we ended up in this situation up here. This is where the two lines are right on top of each other. So this is always true. And again, if you have two parallel lines, that's like when you have a system of equations that's false. There's no point of intersection. So this has infinitely many solutions. Because any point on the line y equals 3x minus 2 will also satisfy 15x minus 5y equals 10. So any point on that line is going to be a solution. Okay. Now another way of solving these systems is called elimination, and this is where you add the two equations together and try and cancel one of the variables. So what I'm going to do in this case is I'm going to multiply by -3, the first equation by -3, and that'll allow me to cancel the 9x with -9x. So let me do that real quick. So I have -9x minus 6y equals -144. So that was this -3 times the first equation. And the second equation is still just 9x minus 8y equals -24. And now I'm going to add those two equations together. And when I do that, I get -14y equals -168. So the positive 9x and the negative 9x canceled. And so now I'm down to a system of one equation with one variable, so I can just solve for y. And you get y equals 12 if you divide both sides by -14. So y equals 12 is the solution for the y variable, and now I need to solve for the x variable. So I have 3x plus 2 times y, which is 12, must be equal to 48. And so 3x has to be equal to 24, because I got 48 minus 24. So x should be equal to 8. Okay, and so my solution is going to be 8, 12. Okay, now I want to look at one of the applications of these sorts of problems, and that's just doing some basic kind of back of the envelope type calculations in business. So it's called break-even analysis, and you want to just kind of figure out how many units you need to sell before you break even or turn a profit. And so remember that your revenue function R of x is just going to be the price you can charge, or the price you can charge for each unit, so price per unit times number of units sold. And typically that's price, and then usually the number of units you're selling is your variable x. Okay, so it's price times x. Now the cost function is going to be the cost per unit times the number of units sold plus any fixed costs or fixed startup costs. And those would be something like the cost of creating a blueprint for a t-shirt that you're printing, or maybe the cost of buying a machine or maintaining a machine for a year in your factory or something. So those things don't depend on how many units you sell, they just depend on a one-time kind of fixed cost sort of thing. So anyways, this is like variable cost, let's say, times x plus your fixed cost. And then your break-even point is when your revenue equals your cost. So you break even if your revenue equals cost. So if R of X equals C of X, then you've broken even. Okay, so let's look at an example. A company that manufactures bicycle has a fixed cost of $100,000. It costs $100 to produce each bicycle. The selling price is $300 per bike. Let X represent the number of bicycles produced and sold. Write the cost function. Well, the cost function is going to be, let's see, well, it says that we have a fixed cost of $100,000 and a variable cost of $100 to produce each bike. So I would write that as 100x, because it's going to cost you $100 for every bicycle that you sell, and x is the number of bicycles you're selling, plus the fixed cost of $100,000. And now your revenue function, R of X, is going to be, well, you make $300 per bike, so that's 300 times X. And then it says determine the break-even point and describe what this means. Well, we're supposed to set R of X equal to C of X and solve. So we have R of X equals C of X, where R of X is 300X, and C of X is 100X plus 100,000. Okay, well then if I subtract 100 over from both sides, I'm left with 200x equals 100,000. So I get x is equal to 500. Okay, so this means that the company must sell 500 bikes before it is out of debt. So what does this mean? This means the company must sell 500 bikes before it becomes out of debt, or to become out of debt. Okay. Now, another thing that we should look at is the profit function. So revenue is how much money you bring in. Profit is the amount of money you bring in minus your costs. So it's revenue minus costs, always. So for any business application, you should just know that profit is revenue minus costs. So in example 4, it says a company that manufactures and sells cat toys has the following cost and revenue functions. So the cost function is 20,000 plus 1.25x. So you have a fixed cost of 20,000 and a variable cost of $1.25 per toy, I guess. And then your revenue function is 8x. That means you make $8 for every cat toy you sell. So it says write the company's profit function for producing and selling X cat toys. Well, that would be profit is revenue, so R of X minus C of X, which is cost. So we have 8x minus 20,000 plus 1.25x. So 8x minus 1.25x would be 6.75x minus 20,000. Okay, that's our profit function. And it says find the company's profit if 5,000 cat toys are sold. So now all we're going to do is plug in 5,000. So we have P, the profit of selling 5,000 cat toys. P of 5,000 is 6.75 times 5,000 minus 20,000. And that will give you $13,750. Okay, so our profit of selling 5,000 cat toys is, like I said, $13,750. Okay, and that's all I have for today. Have a good day.